Welcome to EPG Pathshala. Today we are going to discuss the production and utilization of plant vegetable oil and its conversion into biodiesels. Plant oils are triglycerides of fatty acids and glycerol, and they are converted into biodiesels by esterification to get biodiesel which has properties resembling with that of petroleum diesels. It can be utilized in place of biodiesels in all the diesel operated engines. The performance of the engine on biodiesel is comparable to the petroleum diesel, and rather it is much better as compared to the petroleum diesels. It is more environment friendly and efficiency of the engine is comparable to that of biodiesel. And biodiesel can be used as such without mixing with diesel, or it can be used as a blend of 20%, 30%, 40% with biodiesel, with diesel. Now first let us discuss what is vegetable oil. Plant oil are esters of glycerol and fatty acids, that is mono, di, and triglycerides. Fatty acid consists of hydrocarbon chain bounded by single or double bonds and bounded with carboxyl group. The increased length of carbon chain in the fatty acid increase the molecular weight, viscosity, and melting point, whereas the density of the oil is decreased. The unsaturation tend to increase the melting point of the oil. The number of carbon atoms and double bonds are represented by a general formula N is to M, where N indicates the number of carbon atoms and M represents the number of double bonds in the acid chain. The free acid content of oil is small, normally 2 to 3%. Apart from free fatty acids, monoglyceride, diglycerides, and triglycerides, the plant oil contains phosphatides, waxes, terpenes, gums, etc. The presence of terpene causes bad smell on combustion of the oil and can occlude manifolds and filters of the engine. Now, there are some examples of important oils and their constituent fatty acids like sunflower oil, soybean, maize, and cottons. They contains linoleic acid and which has the formula 18 is to 2. Olive, peanut, and rapeseed oil contains oleic acid. It has single double bond and 18 carbon atoms. Palm oil contains palmic acid, and similarly coconut contains lauric acid with 12 carbon atoms and no double bond. Now glycerol is trihydric alcohol, slightly viscous at room temperature, soluble in water, insoluble in hydrocarbons, sweet smelling. Its melting and boiling points are 18.7 degrees Celsius and 290 degrees Celsius respectively, and has a specific gravity of 1.47 grams per centimeter cube. Now here is the structure of glycerol and fatty acids. Now this photograph shows the crop of Mava oil. Mava is one of the known edible oil and which is more suitable as compared to edible oils for the production of biodiesel. The fruits obtained from the Mava tree are removed, then seeds are taken out, they are dehusked and are converted into oils. And similarly, we have another crop that is Karanji oil, that is also a non-edible oil and has the potential for its conversion into biodiesel. Now, this is the rice crop, and a rice crop gives rice bran oil, and that oil is edible oil otherwise, and it has the potential to be converted into biodiesel, but uh, it is not a non-edible oil, and it is edible oil. Now another non-edible oil is Jatropha seeds obtained from Jatropha seeds, which contains about 50% oil from the kernel of the Jatropha seed, and it is a non-edible oil and has a great potential for biodiesel production in the country. Now the picture shows the fruits of Jatropha. Then fruits each has three um, seeds. Now seeds can be dehusked and the kernel is obtained. The kernels can be further processed for the production of Jatropha oil. Now this slide shows the oil content of some of the important seeds like mustard, sunflower, peanut, olive oil, etc. Now let us discuss the production statistics of vegetable oil in the country. India is one of the major oil producing countries in the world, amounting for about 1/15 of the total production of the vegetable oil. Her per capita oil consumption is around 12.7 kilograms per year, which is much below that of the developed countries where the oil consumption level is 23.5 kilograms per year. The current annual consumption of vegetable oil of this country stands about 22 million tons, whereas the indigenous production with an annual growth rate of 2.5% is about 8.8 million tons. The breakup of the pattern of vegetable oil in the country is as follows. Now, here the point is that India is deficient in vegetable oil. But the point is that the biodiesel is a renewable energy technology which can be used for the production of biodiesel for running the diesel engines in case of any emergent situation arising in future. So that is why the technology is very important for the production of biodiesel. Breakup says that about 55% of the total production is used as refined oil, 20% is used as banaspati ghee. So it means about 75% of the total vegetable oil produced in the country is used for edible purposes. Now, industrial use, that is soap, glycerin, and detergent manufacturing, about 10%, and cosmetics consume about 9%. And Rest 6% is used for miscellaneous uses like paints, varnish, and for energy purpose. Now, scope of use of vegetable oil as energy source. So, it is a renewable source of energy. That means that it can be replenished after a very short period of time. So, it has a crop rotation of, in some cases, it is 1 year, and in some cases, it is 6 months. Its heating value is reasonably high. It is as compared to biodiesel, it is comparable. So it is about 5 or 10% less as compared to the petroleum diesel. Does not disturb the ecological balance. This means that whatever carbon dioxide is used in the formation of the oil, the same quantity of carbon dioxide is released when it is used for energy purpose. Due to low sulfur content of the plant oil, the emissions have practically no sulfur dioxide. So it is environment friendly, and there is no sulfur oxides produced during the use of oil as energy purpose. Compatible with the existing CI engines. So it can be used in compression ignition engines, that is all diesel engines without any modification. And engine exhaust gases contain less carbon monoxide, hydrocarbon, and smoke. So the molecule of the biodiesel contains, or oil contains, oxygen, and because of the presence of oxygen, uh, and there is less carbon monoxide, hydrocarbons, and smoke along with the emissions coming from the engine. It is safe handling and storage. Its flash point is much high as compared to petroleum diesel. So because of the higher flash point, it is storage, more safe to store and transport. Now it also has some limitations, and most of the limitations are related with the higher viscosity of the vegetable oil compared to diesels, especially in terms of its application as engine fuel. That is injector fouling. This is also related with the higher viscosity of the oil. It causes the injection fouling. Increased carbon deposit on combustion chamber, varnish formation on combustion chambers, ring sticking, cylinder wall scoring, and increased fouling of lubricating oil. So these are some of the limitations if we want to use the plant oil as such as the fuel in IC engines. The next is the extraction of oil. Now, oil extraction is being carried by two means. One is the mechanical compression of the seeds to get oil. So, this is the mechanical press which is used for the extraction of the oil. This is the screw conveyor in the picture, and you see the available diameter of the screw as it moves from one end to the other is decreasing and increasing, and with this increased diameter, the space between the barrel and the screw decreases and causes more compression. And because of the compression at the other end of the screw, the oil extraction takes place, and which is coming from the end of the screw, and towards the end is the meal discarded by the machine. Meals contain all the solid particles of the seed along with 5 to 15% oil. So this means that in mechanical compression process, the meal or residual meal which is obtained in the process still contain 5 to 15% oil. So another process is the second process is the solvent extraction of the vegetable oil from the seeds. In this process, there is a counter current contact between the seeds or crushed seeds or flakes of the seeds with the solvent. And finally, we obtain the residual solid mass and a mixture of solvent and vegetable oil. The solvent is extracted by distillation from the mixture, and solvent is also recovered from the micella, which is obtained as a solid residue from the process. Now, from this process, the residual uh, solid mass, which is obtained from this process, contains about 3% oil. So, in other words, if the oil content of the seed is high, then the mode of the extraction of the oil can be followed in such a way that have the mechanical expression first, and that may be followed by solvent extraction process to get the maximum quantity of oil from the seed. This is the structural formula of vegetable oils. It has mono, di, and triglycerides. Now, this is the biodiesel production process where the vegetable oil, which is triglycerides shown in the chemical reaction, reacts with the alcohol. So we can use either methanol or ethanol as the reacting substance as alcohol in the process. And the process takes place in the presence of some catalyst as a some catalyst, normally the alkaline catalyst, and it is converted into biodiesel and glycerol. These are the final products in the process. Now, the variable parameters in biodiesel productions are one is the stoichiometric ratio of oil and ethanol or methanol. So, the stoichiometric ratio is 1 is to 3, that is one molecule of as oil and 3 molecules of alcohol. But to make the reaction move in the forward direction, normally 1 is to 6 1 is to 6 molecular ratio is used in the reaction. Now, second parameter is the alcohol. So we have two options, either we can use methanol or ethanol. Here the point is that if we use methanol, most of the methanol is produced by petroleum uh, products. So in using methanol, we are still depending upon petroleum product or petroleum fuel. But if we use ethanol in the process, then it becomes totally bio process, because ethanol is produced in the country by using the plant materials, that is sugar and starch. Number 3 is the catalyst. So we have the option to use sodium hydroxide, potassium hydroxide, and sodium methoxide. Normally, potassium hydroxide or sodium hydroxide is used in the process, and the quantity used is about 10% of the weight of the vegetable oil. Last is the temperature. The graph shows the time and the ester production at different temperatures, that is 60 degree, 45 and 32 degrees Celsius. But as it is clear from the graph, in the initial stages, the rate of conversion of oil into ester is slow at lower temperature as compared to the high temperatures, but after a period of 4 hours, it is the total production is normally the same in all the temperatures. So the reaction can be carried even at room temperature without affecting the quantity of biodiesel production after a period of 3-4 hours. Now the characteristics of oil, specific gravity of plant oil is slightly higher than diesel and is related to the origin of the oil. It decreases with the temperature. In viscosity, it is represented as kinematic viscosity, which is the ratio of absolute viscosity to the density of the oil. Its unit is centistroke, which is centimeter square per second, and kinematic viscosity of the plant oil increases with increasing saturation and length of carbon chain. It also depends upon temperature and decreases with increase in temperature. Cloud and pour point. Cloud point is the temperature at which the solid starts appearing in the oil. Pour point is the temperature at which oil flow tend to stop because of occlusion of the filters and high viscosity. The pour point and cloud point of vegetable plant oil is higher than diesel but still meets the BIS limits of 6 degrees Celsius. Cetane, next is the cetane number. This is an index related with the pressure at which the air-fuel mixture burns in the presence of a spark or a flame. The cetane number for diesel fuel is 48 to 51. For vegetable plant oil, it is 40. And for oil esters, it is 49. This is also related to the degree of unsaturation and the length of carbon chain. Long chain with 2 or more double bonds have higher bond energy, thus needing higher temperature to vaporize. Heating value. Heating value of vegetable plant oil is about 10% lower as compared to the diesel, mainly due to bonded oxygen. The heating value affects the performance curve of the engine as specific fuel consumption increases and power output decreases in the engine. Next is the distillation curve. This refers to the fuel volatility and provides information concerning the air-fuel mixing system to be used and the regularity of the distribution in combustion chamber. For vegetable plant oil, it starts at 310 to 360 degrees Celsius, whereas for petroleum diesel, it is 160 to 200 degrees Celsius. And for plant oil, it ends at 810 degrees Celsius. The distillation range for esters, that is biodiesel, is 300 to 360 degrees Celsius. Next is the flash point. It is defined as the minimum temperature at which the vapors formed catch fire on ignition. The flash point of vegetable oil is much higher as compared to diesel. High flash point ensures the safety during storage and handling of the fuel. Next is the condensation index. This gives information regarding the carbon residue during combustion of the fuel. It is higher for plant oil as compared to diesel. Next is the ash content. Ashes are derived from the solid particles of fuel or from soluble metallic compounds. These are harmful for engine operations. Next is the iodine number. It is milligram of iodine that can be bonded to 100 gram of oil. This indicates the number of double bonds. Unsaturation is good as far as the filterability concerned. Flow is concerned but negative in terms of oxidation stability. High iodine number fuel have high condensation index, increasing the solid residue. Now next is the total acidity, and this is the milligram of KOH required for saponification of free fatty acids in the oil sample. Crude plant oil has an acidity of about 3 milligrams of KOH per gram, whereas for refined oil it is about 1 milligram of KOH per gram, and for biodiesel it is less than 0.5 milligrams of KOH per gram. Free fatty acids from salt with metals at high temperature causing damage to the engine. Now this table shows the characteristics of sunflower oil, that is refined oil, and its biodiesel produced using methanol and ethanol, both as the reactants. Now the specific gravity of oil is 0.91, and this M ester indicates the ester or biodiesel produced using methanol as one of the reactant, and E ester indicate the biodiesel produced from ethanol as one of the reactant. Now the specific gravity is a little higher as compared to diesel of methyl as well as ethyl ester. Then kinematic viscosity of methyl ester and ethyl ester is comparable, not much different, and it is about double that of the diesel, but it is 6 times less as compared to vegetable oil. Now, the calorific value of both methyl and ethyl ester is comparable, not much different, and it is slightly less as compared to diesel. Then flash point is the major difference. For diesel it is 79, whereas for methyl and ethyl esters both it is about 170 degrees Celsius. So this indicates its safety in its storage and handling. Then cetane number for methyl and ethyl esters it is comparable, and it is higher as compared to petroleum diesel. Now this diagram shows the production process for the biodiesel in a batch reactors. So now it has two reactors. In the first reactor, oil, catalyst means sodium hydroxide, and the quantity of the catalyst normally kept for the process is 1% based on the weight of the oil. And methanol or ethanol. So methanol and the catalyst are mixed in a mixer and fed to the first reactor, and oil is also added over here. Now the sufficient time and temperature is allowed for the reaction to take place, and after the reaction is completed or it is uh, available in two phases. One phase contain the glycerol and water, and the other phase contains vegetable the biodiesel Now the phase which contains glycerol is hydrophilic phase, which is heavier and gets settled at the bottom. The upper phase which contains biodiesel is lighter and floats over that glycerol layer. Now the upper layer is transported or transferred into the second reactor where some acid oil is added again to complete the reaction, and the purpose of adding acid is to neutralize excess of alkali which has been added into the process as a catalyst. Now the bottom phase from both the reactors which contain glycerol can be transferred to the Glycerol Recovery Unit, and the upper layer which contains biodiesel can be sent to the Methanol Recovery Unit, and it is then separated into methanol and biodiesel. This is again a batch type, very simple process, and which was developed at Punjab Agricultural University, Ludhiana. Here the crude oil is heated to a temperature of 60 degrees Celsius, and in a separate chamber methanol is mixed with 1% sodium hydroxide and heated, and then both the crude oil and methanol are mixed together in a mixing tank and then allowed to settle for 4 to 6 hours. Now, during this settling period, the reaction takes place where the oil is converted into biodiesel and two layers are formed. One is the hydrophilic layer, which contains glycerol and water, and the other is hydrophobic phase, which contains methanol and biodiesel. The hydrophilic phase is then washed with water 2 or 3 times, and in washing what is done, it is mixed with water, stirred and allowed to settle for some time. And again the two phases are formed, and the upper layer, which is lighter, contains biodiesel, is separated, and finally it is heated to remove the traces of water, and the pure biodiesel is obtained. Now the biodiesel thus produced can be used in any diesel engine without any engine modification, and there are no detrimental effect on engine operation and its life. Engine exhaust is more environment friendly compared to diesel operated engines. Plant oils using the esterification process are converted into biodiesel, which can be utilized as such without any modification in any CI engine. Any diesel engine, that may be a mobile engine or a stationary engine, can be used or can be operated on biodiesel. The operation of engine on biodiesel is even better as compared to the petroleum diesel operation in terms of lesser uh, emissions of carbon monoxide and hydrocarbons in the engines operated on biodiesel as compared to the engine operated on diesel, petroleum diesel. It is more environment friendly, and the efficiency of the engine is even better as compared to the biodiesel production. Thank you.